Hello everyone, I am Abhishek Sangvi. I am Solution Architect by profession. Today, we will be giving a quick glance on the common AWS offerings. For that, I will be drawing a system design for a simple social media application. First, I'll draw it using legacy on-prem solutions, and later we will see how the on-prem solution can be modernized to the cloud-based offerings. I will use AWS services for this example. So let's get started. I'm using draw.io for my drawing. So I'm starting it as a scratch. Let's take an example like a social media application. So I'll name it like maybe social media drawing. And I'll start as a blank diagram and to create. And I'll save it in my local somewhere. So on the left hand side, I kind of started these with styling. And then I like it more without grids. So I'm removing the grid section here. And let's get started. And then I'm keeping the page's landscape so that I can have a landscape orientation of the diagram. Okay, so first thing first, I think I need a private network. So for now, I'm just putting a dotted line here. Let's assume we have a small scale startup application for the social media. So we will have like let's say 100 or 200 users. Keeping those in mind, I will just need maybe one web server with a single virtual machine. Because it is kind of in-house experimental thing, and then one physical disk on this web server, and I'll mark it as disk. Keep the font size at 16, and then reduce it. Okay. So that's my VM, and I can name it as web server. And then similarly, I can have a placement for application server. Similarly, VM and disk for the application server. Now for this one, I'll need a database. So let's draw a database here. And then this DB would be connecting to this database. So database name, and the web server would be talking to VM, the application server, and then let's say I have users here. I'll take this as users. Okay, so these users would be hitting to this web server and then application server. The web server will be storing some information in the local disk, and then whatever information needs to be persisted then goes to the database, relational database. So that's a very pseudo, very high level startup application with around 100 to 200 like in-house user or kind of in our close contact. But then let's say the scenario where our volume like started increasing and people are liking our application and they started using it and our website is doing good. So people do like it. Before that, let's see if we want to name our website something.com, like xyz.com. And for that, we will need DNS. So let's see if we can place a DNS here, like something.com will network through the DNS. And then this. Now let's say my volume is increasing and I need more web servers, more application servers to support those volumes. So there are two kinds of scaling I can do. One is vertical scaling and other is horizontal scaling. So for vertical scaling, I would increase the capacity of the individual machine and the disk and work through it. But in this case, probably the individual, my volume is growing too much and I need multiple server instances to do the horizontal scaling. So I'll create more instances of web server, more instances of application server. So in this case, because I'll be using multiple instances, I'll need a load balancer here. And then the load balancer will be hitting the individual web servers, and then web servers will be load sharing with application servers. Let me just beautify these. Now the second scenario is that I have a lot of data. So I mean, like, because the volume is growing, as well as like people are using it too much, maybe loading a lot of data, and maybe the relational data is not scalable enough. It cannot carry that much of information. So maybe I need some of the bulky data or big data to be placed on an NoSQL setup. I need NoSQL. Now, talking about the scenario, because we're using social media, let's say people are loading a lot of pictures, videos on daily basis, and if these disks are not like good enough to store that information at web server and application server level, as well as the databases are not a good placement order for those pictures and videos. So documentation. So and these media files will be placed in an external storage. That's just okay. And let's say I need to, after I store it, I need to, I mean, so these are large files, like let's say videos are there, and those are kind of high definition videos which are good for the browser, but for mobile we need to have low bandwidth data videos. So we need to convert these video in different formats so that mobile users can use multiple different formats of their choices. So let's say we place a video converter here, and these videos will be directly, I mean, other users, I mean, the one who loaded it, and then other users are watching this video. So let's say these videos, there's a direct URL where people can fetch this information from an external storage. So let's say people are using it using web browser. And for this, we'll be needing the content delivery network, so that because the same video will be loaded by multiple people in the same local zone, it doesn't make sense to have this information being loaded every time the user clicks. So let's say our external storage is placed in United States and people are watching this video from India. It doesn't make sense to have every time it's loaded from our external object. So we will need a content delivery network here. So let's say we have a now let's say that these videos people are loading are, I mean, there is some content of this video which is not acceptable. Let's say we want to do some content filtering here, and for that content filtering, we'll need a content filter. So let's say the objectionable content we don't want to store in our record. There are legal reasons so that we cannot do it. So let's make a content filter here. Okay, now the next scenario is where, let's say we want to use some of the advertisement. We want to watch activities of our people, using how people are using our social media application, what they like, what they don't like. We just want to do some click stream analysis. So let's make a case for click stream analysis. And then Again, same for the clickstream analysis. We'll need, after the clickstream analysis, we'll need an external storage. So and then after the external storage, we'll need some kind of big data analysis. Like we'll need some computing of distributed systems. So for that, we'll need some big data system. So let's say we will be using maybe Spark or Hadoop. So let's say for data analytics, year-end reporting and etc., we need a data warehousing system. So let's say after data warehousing, we'll be needing a business intelligence system. So okay, next scenario is for notifications. So let's say I have my application servers. We need to have like SMS going out from my application server for different functionalities, or maybe mobile push notifications. So we'll need some triggers from these servers, and then we'll need those systems or services handled. So let's take it one by one. So we'll have push. And same applies for emails. Like we'll also need email notification to our customer. And then similarly, we may have a scenario where we need a chat facility, like people talking, messenger or chat system where people are talking to their friends on their social media. So we'll need a queue kind of setup, like JMS queue, IBM queue, Evident queue, something where we can have a chat functionality supported. So I can mention chat. Other than this, we'll need some monitoring on our system. So let's say we'll need a monitoring dashboard. So that will be basically watching the overall system here. Okay, so that's one more thing we can think of is that the database and the NoSQL. Let's say from NoSQL side, we have a lot of data, big data, a lot of data placed here, and we want to have it loaded to our business intelligence and data warehouse. So we'll have a Spark Hadoop big data processing system. So we'll need to have something from our NoSQL going to the Spark Hadoop, and we'll need some ETL transformation here. Okay. Okay, now we'll need, I just kind of draw a few lines here just to give me an idea how to place things, but we'll need a box here to represent our private network. So and we'll need a text box here to represent this private network. And then I'll need some dotted line. Okay. Now, one more scenario I could think of is that because my volume is growing now, and we need, like, for every time we are fetching information, the things like which are repetitive in nature, you can have one query and like all users are using it. I mean, maybe some kind of news feeds or something. You do not want to hit your database for every time a user moves a page. So you will need some kind of DB cache like name cache. For that, you would need to place something in front of your relational database. So for that, you can place a DB cache here. Yeah, so that's our, I mean, very in simplified format, a very simple on-prem solution for social media application. So till now, we drawn a on-prem solution, like things which are not on the cloud, but how we will draw a social media application, very high level, a simple social media application with using on-prem solutions. Now let's move forward towards doing the modernization of this legacy application and move it towards cloud. And for that, I'll be using AWS offerings. I mean, we can use similar offerings from Azure or Google Cloud GCP. But for this example, I'll be using AWS offerings here and see how, and we will progress towards one by one for each piece as a replacement for AWS offerings. Let me rename it to say on-prem. Okay, so let's start with the private network. For private network, similar concept in AWS cloud setup is VPC. So let's replace it with VPC. Next thing is VMs, our physical machines. We have VMs at web server as well as at application servers. Those VMs, the corresponding thing in AWS world is EC2 machines. So we can similarly for disk in AWS we have EBS, Elastic Block Storage. So which So we'll do the same thing for all VMs and all this. Now we can, like in AWS environment for cloud, what we can do is we can do auto scaling. That's a great feature of cloud we can have. So I can place an auto scaling here for these VMs. So what auto scaling will help us for this VM is that because these are virtual environments and you can dynamically add number of instances, reduce number of instances. So this auto scaling do it for us. So if the load increases on the application, the auto scaling will create new EC2 instances and the horizontal scaling will happen automatically. And then the same thing, like when the load is lower, maybe during night time or maybe during the time when there are not many people are coming, the auto scaling can help us bring the number of EC2 instances down so that our cost would be low. Now let's move towards databases. So for relational database, we have AWS offering RDS, which is Relational Database Services. It's a managed service by AWS. So we can use this one. For NoSQL, AWS has DynamoDB. For DB cache, AWS have Elastic Cache. I mean, you can use Redis or Memcache from an AWS Elastic Cache managed service offering. Now let's move up. We need to replace the load balancer. So we have for AWS, we have ELB, Elastic Load Balancer. Next is this DNS service. For this in AWS, we have Route 53. Now let's move further to the right. We have this external storage. For this in AWS, we have S3 as an object storage service. For content filter, we have recognition in AWS. So it's doing the same job of looking at the stream of videos and doing content filter activity. So recognition. For this video conversion activity, we will need some computing power, which can be serverless too. So we can use Lambda here. For this section, clickstream analysis. For this section, clickstream analysis, we have offering from AWS Kinesis. Okay, for big data portion, for our traditional on-prem solutions, this is Spark and Hadoop. From AWS, we have offering a service offering as EMR, Elastic MapReduce. This works for aggregation, sorting job kind of activities. Okay, now in this section, ETL, extract, transform, and load, we have Glue. Glue is an AWS managed ETL service. Similarly, for data warehousing service, we have in AWS, we have Redshift. So the data warehousing will be replaced by Redshift. Okay, for the purpose of business intelligence, couple of AWS service offerings are Athena and QuickSight. So the combination of both can be used to work as a business intelligence. Let's look at the top portion. We have CDN here, Content Delivery Network. For this, the AWS offering is CloudFront. So it's same as the CDN solution. The CloudFront allows us to have data cached for our users. Like maybe if the videos needs to be watched frequently or by many users with different edge locations, the CloudFront can help here. And then CloudFront work with edge locations. So for each edge location, they keep the data cached here. Now let's move on the left side. We have this mobile push notification system. For this one, we have an offering in AWS that's called SNS, Simple Notification Services. Similarly, for emails or email notifications or bulk emails, we have offering called SES, Simple Email Service. Similarly, for messaging queues or you can say chat service, we have an AWS offering that called SQS, Simple Queue Service. For monitoring and monitoring dashboard, we have primarily AWS services, AWS CloudWatch, and then we can also use AWS Alarm here with AWS CloudWatch for additional services. So this covers our on-prem solutions and their alternate AWS offerings. All of the on-prem solutions we had, we replaced it with the AWS offerings. So if we want to look at a very high level, this is how we can have our existing on-prem solutions can be modernized with the AWS components. Till this point, we have completely replaced on-prem solution with AWS services, and I hope you got some idea about all these basic AWS services. Now let's see some application services offered by AWS. As you know, most well-known technology companies exposes all their services through API calls so that different third-party applications can integrate with these applications. To achieve that, they need an REST API service. AWS offers managed API gateways where it takes care of scaling, throttling, etc. We just need to write business logic of our APIs and deploy in API gateway. We can have mobile users or web users, and we need to manage their identities. Like users must sign up to our application. We need to manage our user pools, their accesses, etc. And for that, we need some user management service. For this purpose, AWS offers Cognito for user management service. So this is all about application services offered by AWS. Now next, let's move to AWS security services. So the first one is IAM, Identity and Access Management. IAM is primary service for managing all accesses in our AWS infrastructure. For example, AWS users. To determine what access AWS users have and what services these AWS users can use. Not only AWS users, but even if one AWS service like EC2 wants to upload a data to other AWS service like S3, then EC2 needs permissions to perform this action. These authentication and authorization is managed using IAM service. This is one of the most important service for securing our AWS account as well as services. Next is Key Management Service, KMS. We need to encrypt our data, which is stored at various storage locations like EBS, S3, EMR, Redshift, databases, in-memory caches. All these data we can encrypt using Amazon's KMS service. It manages all the encryption keys for us. We don't need to have our own secure location where we can store our keys and do the encryption. Next is ACM, Amazon Certified Manager. As you know, our application will be accessed probably over HTTPS, which is SSL enabled connection, because if users are doing some transactions or they don't want to lose their important information, we need to secure that communication. And for this, we need digital certificates. We can deploy these digital certificates either on our load balancers, or we may deploy it on CloudFront to keep our communication secure. For this, AWS has a service called ACM, Amazon Certificate Manager. We need application firewalls, and for that, another service by AWS is called WAF. Web Application Firewall. This service takes care of any attacks it can prevent, like cross-site scripting, SQL injections, or DDoS attacks. Web can protect our application from these attacks, and we will typically deploy it on CloudFront or on load balancers. Or we can also deploy it in front of our API gateways. There are additional protections by using VPC to secure the network, but here we are talking about application level firewalls, which is provided by WEF. Next is AWS Inspector. Our application will also be going through audits or compliance reviews, for example, PCI or DSS compliance, or maybe HIPAA compliance. So our machines need to be patched properly. These machines should be free from vulnerabilities, and for that, we have this service from AWS called AWS Inspector. It places an agent inside our machines, and it scans our machines for any known vulnerabilities, and then it will give us vulnerabilities reports. So Inspector can give us insights about what's there inside our machines. So till this point, we covered primary security services offered by AWS. There are more, but I think we will restrict our discussion to only these services. Let's move to development and DevOps services offered by AWS. This architecture has a lot of AWS services and all are connected. So when we will deploy everything manually, it will take a long time. It will have human errors, and also it will need manual troubleshooting. Here, AWS offers ability to code your infrastructure that's called IaaC infrastructure as code. This AWS service, CloudFormation, takes a template which is in JSON or YAML format, and it will create this infrastructure from scratch for us within minutes. CloudFormation is a very powerful service which can provision our infrastructure from scratch. DevOps team usually write these CloudFormation templates. Also, developers write code for our application product, and maybe QAs will write test automation. All of these people will need some kind of code repository, like Git code repository. For that, AWS has a code commit service where we can check in the code. So even this CloudFormation template is nothing but a JSON or YAML code. So DevOps team will write that as a template, place it inside code commit, and then those templates will be taken by CloudFormation service and then create this infrastructure. Now, once we have this infrastructure up, we need our actual application or product to be built. And for that, we need code build service. So Amazon code build will take the source code and it will build using build tools like Ant or Maven. Also, while building it, it will do some unit test, and finally it will produce some artifacts. Then we have to deploy these artifacts, and that means we have to place these artifacts and binaries in EC2 machines where our application is actually running. So we will need a deployment service. And for this, we have offering from AWS called Code Deploy. Now, this Code Deploy will do these deployments to individual application servers after creating the artifacts. Now, if we need CI/CD pipelines, continuous integration pipeline or continuous delivery pipeline, which will ensure automated integration or delivery as soon as developers check in the code, it gets built and tested automatically and deployed automatically into corresponding application servers running in EC2, then we can use the code pipeline service offered by AWS. Now, if you want to further integrate all these things with project management tools like Jira or any other task tracking tools, as well as other development management tools, we can use AWS CodeStar service. AWS CodeStar very well integrates with Atlassian Jira and other tools, so we have complete SDLC control. We covered important development and DevOps services offered by AWS. If you have come up to this point, you know about most of the AWS core services for compute, analytics, storage, security, application, and deployment services. Thank you very much for joining with me.